Okay, so this is a video for exploring the graph of trig functions. Last year I had students do this on a day that I was absent by themselves, just using the facts from the unit circle. But I'm going to do this one with you just to make sure our graphs are correct, because next week we'll start graphing these functions. Okay, so in order to do this, if you look at what I'm asking you to fill in here, it says use the unit circle to sketch a graph of one cycle of the curved function y equals sine of x. So what we want to do is we want to plug in this x value right here and then say what that is. So I want to find the sine of 0. Okay, so if you think about this, I need to do sine of 0, sine of pi over 2, sine of pi, sine of 3 pi over 2, and sine of 2 pi. So what I'm going to do right here is I'm going to make a little teeny tiny unit circle. And I only need my quadrantals. I know that's not a good circle, but hey. I only need my quadrantals because I need 0, I need pi over 2, I need pi, 3 pi over 2, and then 2 pi, right? So, and I need this sine value, okay? So I'm going to write the ordered pairs for everything. This is over 1 up 0, this is over 0 up 1, this is left 1 up 0, and this is over 0 down 1. Okay, so now I'm going to get the sine value. Remember, the sine value is the y value. So that is 0. I need the y value at pi over 2. That's 1. I need the y value at pi. That's 0. I need the y value at 3 pi over 2. That's -1. And then finally, I need the y value at 2 pi, which is back to where we were, 0. Now what I want to do is I want to go through and graph these 5 points. These are the 5 points that make up one cycle of the curved sine function. Okay, so I'm going to graph 0, 0, over 0, up 0. That's the origin right there. I'm going to go right pi over 2, up 1, so I have a point right here. Then I have the point over pi, up 0, over 3 pi over 2, down 1, and then over 2 pi, up 0. These are my 5 points that are going to make my curved function. So now I'm going to go ahead and connect these points with a curve. And that's what one cycle of the sine function looks like. If you notice right here, this is actually the top of the unit circle. This is the bottom of the unit circle. So together it forms a circle. Okay? All right, now we're going to do the same thing, but for a cosine function. So I want to plug in 0, which I already have this thing for help right here. So what I'm going to do is I'm just going to move it down right here to use it. Okay. All right, but this time I want the cosine values. The cosine values are the x values. So the cosine at 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is back to 1. And now I'm going to graph these points right here. So I have the point 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, 2 pi, 1. Okay, so if you were connecting these with a straight line, notice this would look like a V. But it's not a straight line. I need to move this one down a little bit. Swoop. There we go. But I am not connecting the straight line. I'm connecting it with a curve. So this is like the upper right-hand part of the unit circle. This is the bottom part of the unit circle. And this is like the upper left-hand part. And when I say that, when I say the upper right-hand part, I mean this part is this part. Then this part right here is this right here. And finally, this part right here is this right here. You see that? Okay. So let's summarize sine and cosine real quickly, what they look like. So if I were to draw a line directly through the middle of the graph, which would be right here, which is at the line y equals 0, notice where my points lie. For sine, it's on the midline, above the midline, on the midline, below, on the midline. So that's how I remember what the sine function looks like. For cosine, if I were to draw a midline in there, right here, okay, cosine is above, on, below, on, above. That's how I remember them, okay? Okay, last but not least, we're going to look at tangent, okay? So the tangents that I ask you for, the sunlight's glaring in my eyes here. Okay, when I'm asking for tangent, I'm asking you for tangent of negative pi over 2, tangent of negative pi over 4, tangent of 0, and tangent of pi over 4, and tangent of pi over 2. So remember, I'll start off by doing tangent of pi over 4 because I have that memorized. That's tangent of 45 degrees. That answers 1. Okay, but let's get the other ones here. So I'm going to draw my unit circle. First off, let's do negative pi over 2. So realize negative pi over 2 is in this direction, and it's right here. So what's the ordered pair right here? This is over 0, down 1. When I want tangent, I use the y value divided by the x value. So negative 1 divided by 0. Can I divide by 0? No. That means it's undefined right here. I'm just going to put UND for undefined. All right, now we're going to do negative pi over 4. Think about where negative pi over 4 is. That's right here. Okay? Now it's a pi over 4 angle, which is 45 degrees. So I know my answer is going to be 1 or negative 1. Let's use all students take calculus to decide if it's 1 or negative 1. Cosine is the only thing positive in this quadrant. That means tangent is negative. So this is negative 1. Now let's do the tangent at 0 degrees. So here's 0 degrees. That's the ordered pair 1, 0. Remember, this is the x value and the y value, and tangent is y divided by x. 0 divided by 1 is 0. Last but not least, I need the tangent at pi over 2. Pi over 2 is right here. That's over 0, up 1. Once again, this is x, this is y. If I do y divided by x for tangent, I get undefined. So what we're going to do is we are going to graph what we have so far. At negative pi over 2, it's undefined. If it's undefined there, it's because we have an asymptote there. So we're going to draw on a vertical asymptote at pi over 2. And while I'm here, I might as well draw on one at pi over 2 also. All right, so now I can graph negative pi over 4, which is halfway in between 0 and negative pi over 2, or negative pi over 2 and 0, I should say. And then I have a point at negative 1. I have a point at 0, 0. And then I have a point at pi over 4, comma 1. So over pi over 4, up 1 is right there. Remember, this is a curved function. So this is what tangent looks like. And that's one cycle. So realize when I say it's one cycle, this actually keeps going and going and going and going and going in both directions, because I remember I have all these angles coterminal. I went way too low for that one that way. And this one right here repeats over and over and over again, but the directions say one cycle, so we're only drawing that one cycle. Okay? All right, so this is just a sketch, an idea of what these look like. So when we start graphing them next week, you'll